Hello everyone. The topic that we will be discussing is on electric field intensity due to an electric dipole at a point on its axial line. To proceed further, let us have an idea on few important terms like electric dipole or simply dipole and dipole moment. Dipole moment. So what do we mean by electric dipole? A pair of equal and opposite charge separated by a small distance is called an electric dipole. If you have a minus q here and then plus q separated by a small distance, say 2L, or we can write R. So this is an electric dipole. The product of the magnitude of any one of the charge with the distance between them is called a dipole moment. So it is denoted by P, which is equal to Q into 2L. In vector form you can write P vector is equal to Q into 2L, so P cap. So the question may arise, where is the direction of this dipole moment? The direction of this dipole moment is from negative to positive. So now we have an idea about electric dipole and electric dipole moment. Let us discuss on the electric field intensity due to an electric dipole at a point on its axial line. So first of all, let us know the meanings of the axial line. So what is an axial line? A line passing through the positive and negative charge of the electric dipole is called the axial line of an electric dipole. If we have a minus q here and a plus q, so they are separated by a small distance, say 2L. Separated by a small distance 2L, and if we draw a line passing through minus q and plus q, if we draw a line like this passing through minus q and plus q, this line is called the axial line. Now we want to find an electric field intensity at any point on the axial line. So let P be any point on the axial line which is at a distance, say R, from the center O of an electric dipole. So from here to here is 12, so half of it becomes L, and from here to here it is 2L, so half of it, this one is also become L. Say this point minus Q is at A and this plus Q is at B. Now, what is the electric field at a point P due to minus Q? The electric field at a point P due to minus Q is in this direction. So we will map the electric field at P due to minus Q at A is E1. Why? Because the electric field, the direction of the electric field is readily inward for minus Q, and the electric field at the point P due to plus Q at B is in this direction. E2. It is in this direction. Why? Because due to plus Q, the electric field intensity is readily outward. So, what is the distance of a point P from minus Q? The distance is R plus L. From P to O is R. So, from O to A is L. So, the distance from A to P, or P from A, it is R plus L. And what is the distance of plus Q from P? It is nothing but R minus L. So what is E1 now? What is E1? E1 is 1 by 4 pi epsilon naught. So Q divided by, so the distance of this point P from A is R plus L. So become R plus L whole square. In which direction? I can write minus I cap. Let us choose that if it is in this direction, the unit vector is I cap. Then opposite to I cap is minus I cap. So E1 is opposite to I cap. So we can write minus I cap. That's the direction of E1. And what is E2? E2 is 1 by 4 pi epsilon naught. So Q divided by R minus L whole square with I cap. This E vector is along I cap. It is in direction of this unit vector. So we can see from here E1 and E2, they are collinear. They are collinear, but they are opposite in direction. E1 and E2 are collinear, and also they are opposite in direction. So the net field at P, can be written as E2 minus E1. So the magnitude of the net field at P, it is E2 minus E1. Or we can write magnitude of E. So this become E is equal magnitude of E2 minus magnitude of E1. That is, we can mark this one as equation 1. So mode of E2, it is nothing but 1 by 4 pi epsilon naught. Then Q divided by R minus L whole square minus 1 by 4 pi epsilon naught. So Q divided by R plus L whole square. The question may arise, why E2 minus E1? The reason is the magnitude of E2 is greater than E1. So one should be noted that the magnitude of E2 is greater than E1 in this case. Because the distance of a point P from a point B is smaller than the distance of a point P from A. So that's why E2 is greater than E1. So from here, we can take common Q divided by 4 pi epsilon naught. So 1 by R minus L whole square minus 1 by R plus L whole square. Then what is E? E is equal to Q by 4 pi epsilon naught. Then 1 by R minus L minus 1 by R plus L. This one and this one, we can find the LCM. It is R minus L whole square into R plus L whole square. Take this one to the side, become R plus L whole square minus R minus L whole square. So this becomes Q by 4 pi epsilon naught. So R square plus L square plus 2RL, then R, so minus R square plus L square minus 2RL. Divide by R. A minus B into A plus B become A square minus B square. So square square should become whole square. Then from here, so Q by 4 pi epsilon naught, R square minus into plus become minus, so R square with minus R square will get cancelled. Similarly this one will get cancelled, so we will remain with 4RL divided by R square minus L square, then holding square. So this is E. So this is the magnitude of the electric field intensity at P due to an electric dipole. So in vector form, what is E? It is equal to Q by 4 pi epsilon naught 4 RL divided by R minus L. So here square holding square. In which direction? The net field is along E2 because E2 is greater than E1. So you can write. So this is the vector representation of the electric field at a point P due to an electric dipole. So let us discuss now special case. If R is very large in compared to L. So what is R square minus L square? It is approximately equal to R square minus L square. It is approximately equal to R square. So what is E? E is equal, the magnitude, it is Q by 4 pi epsilon naught. If you take the magnitude, so mod of E become E. Mod of I, this is unit vector, it become 1. So 4 RL divided by R square minus L square become R square. R square with this square become R4. So this and this will get cancelled, we get 3. So what is E? E can be written as 2 by 4 pi epsilon naught, or 1 by 4 pi epsilon naught, then twice L into Q. Here we can put 2. 2 into 2 is 4. So this L and this Q divided by RQ. So what is this 2L into Q? This 2L into Q, so E is equal 1 by 4 pi epsilon naught. So twice 2L into Q is P. It is a dipole moment, the magnitude of dipole moment. So divide by RQ. So in vector form, what is E? E vector is equal 1 by 4 pi epsilon naught 2p vector divided by RQ. Why I write p vector? Because the direction of this dipole moment is in this direction, and the direction of electric field of the net field is also in this direction. They are in the same direction. So that's why we can write E is equal to 1 by 4 pi epsilon naught 2p vector divided by r cube. So from here, we can see that if the distance of a point P is very far from the center of the dipole, the electric field E is inversely proportional to